Hey guys, welcome back to the shop. So we're gonna get back on our friction shaft here. What we have left to do is mill the 4 Woodruff keys. We're gonna jump on that now. So let me pull you in here and show you, I got a new arbor and a new cutter to get this job accomplished, okay? So we've already got a previous video on machining it in the lathe, and now we're gonna be milling the 4 Woodruff keys in this shaft right there. So I found the proper size cutter that I need to do the large Woodruff key, which is a size 1622, which is half by 2 3/4, and that's what this guy is right here. I ordered a stub arbor. This is a brand new stub arbor. It's the TMX brand, 3/4 shank, 1-inch stub on it right there. This is what I could find quickly. I was hoping to find a 40 taper stub arbor, but I couldn't find one and get it here quickly. So hopefully this is going to be rigid enough. I do have a 3/4 inch end mill holder that we're going to put this in, and hopefully that'll make it rigid enough to do our cut. Our smaller Woodruff key, that is going to be a number 1610. So I ordered a brand new. This is a Keyways brand, number 1210 Woodruff cutter, 3/8 diameter. I'm sorry, 3/8 wide by 1 1/4 inch diameter. So that's going to be the cutter for those guys right there. So they do fit in there good. We'll set this one in there. You can see that it fits good. So that's it. What we'll do, I went ahead and marked the locations, the center from the end of the shaft. And all we'll do is we'll just use a pointer here to line up our mark. If it's off just a little bit one way or the other, that is not going to kill that on that shaft. So we're just going to line up with our Sharpie marks on both ends. And then we'll put our cutter in there, move our offset, and get to cutting. We're going to be using our KBC milling machine to get this job done. I'm hoping that we've got some good rigidity in this machine. I'm going to set up the Noga Cool for the coolant whenever we get to cutting there. But I wanted to show you the setup. So we're going to be utilizing both of these milling vices. The Kurt vise is already trammed in there, and I was able to set the shaft in there, and both of our cuts are going to be right here in between the 2 vices. So I clamped it in here nice and level and straight, and then I slid this older milling vise up underneath it and just simply run the vise jaw up until it naturally centered itself up on the shaft, and then put a couple hold downs there to hold it in place. So it is in the center of where it needs to be. So I think this is going to provide some good rigidity for the milling operation here. Centering up on the first keyway there, using the pointer, we're in absolute. Got the X and 0. Now what we'll do is we'll put it over into incremental and come down and find our location here for this keyway, and then zero out the X axis for that as well. Just get it eyeballed right about in the center, right there. And looks like it's going to be 5.5 inches center to center. So I'm just going to go ahead and move that over a few more thou. 5.5 inches. We're going to go to incremental. And I'm going to zero that right there. So now we can just switch back and forth from absolute to incremental to line up on our 0 location for our X axis there. All right, we're going to get our Z offset established for our 1 1/4 inch diameter cutter there. Once we go over here to our bigger cutter, we're not going to be able to touch off on the shaft like this. We're going to have another trick that we can use to find the top of the shaft there. We'll get to that later. But we're going to use our paper trick for this. So we're just going to simply slide that paper underneath there, and I'm going to work the Z elevation up, and then once it just kind of pulls that paper out of my finger there, we're going to be offsetting it from that location. So I'm just eyeballing, I'm getting it really, really close where I can still see a little gap underneath there, and that's going to be good. So here we go. Matter of fact, let me get it under there first. Just like that. You just hold on to it very lightly, and it'll just pull it right out of your fingers. I'm working the knee up. I feel it starting to grab that paper. Just like that. I'm going to remove it off the shaft, and that should put you within 1 to 2 thousandths of being to the edge of that shaft right there. So I've already calculated to our center there. You just divide the shaft diameter by 2, take half of the width of the cutter, add those together, and that's going to be your Z offset. So we're going to be at 1 inch 31 thousandths. Got this set on 0 and we're clearing the shaft. So 1 inch 31. I do not have a Z on the digital readout on this. So we just have to use our dial here. So that was 100, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now we're going to go another 31. 31. Now we should be in the center of that shaft. We're going to be using our Noga Cool. Let me go ahead and make sure it's set right. That way we can hopefully just turn it on. I've already got the air hooked up. Slow it down a little bit. That looks pretty good. You can adjust your amount of spray you want by this nozzle here. All right, I think that's going to be pretty good. For speed, I'm going to be running right around 50 surface speed. I wanted to kind of play it easy. We're cutting 4140 and we're using high-speed steel. So for high speed, I usually just kind of ballpark figure 50 surface speed. So I've got it set at 150 RPM. I'll come here and see if I can get me a flat. We've got the table locked. About like it right there. A couple more. All right, now we've established the flat there. I know that you can't see it, but I'm looking across here right here, and I can see a tiny little line on the bottom of the cut there. So that's going to be our 0 point that we're going to start with. I'm going to come in here to where it just touches right there. I'm going to zero out my Y. And we are ready to make our cut. Let me see what the depth is. I had that calculated, I got it right up here. So our depth should be 0.354. All right, here we go. All right, there's our 0. You're gonna get a little chatter. There's really not much we can do. Let me slow it down just a little and see if that'll actually help it. Doesn't hurt to run these a little bit slower. I took one of our new Woodruff keys here and just dressed it on the pedestal grinder just enough so that we could slide it in there, because this had about 1,000ths interference. These were just a little bit big. So we got it where we can push it in there now. Kind of get it centered up, and we should have 3/16 above the shaft for our key. And you can see just a scale measurement, you can see right there, we are at 3/16. So we are good to go on the depth there. Now, alternatively, you can also calculate your height by using a micrometer and measuring from the back of the shaft over on top of the key, and that'll measure exactly what you're supposed to, or what your key is measuring if you need to take it a little bit deeper. But this is working out real good, so we've got the first one cut. All right, so we're gonna move on to our large Woodruff key there. Now, the problem that we have with this is that because of the the nut here and the diameter of the cutter and the diameter of the shaft, we're not going to be able to get in here all the way to the top dead center of our shaft and get our touch off there. You're not going to be, just can't get to the center. So I've got another trick that I can show you that we can use to manipulate what the height of this shaft is going to be, and use something else that we can touch this cutter off to get our Z offset. So we're going to use one of our old school machinist tools right here. This is called a planer and shaper gauge. It's like an adjustable parallel. So this piece right here slides up and down along this angle, and you have a T-nut inside there that you can tighten up to adjust this wherever you want. So this tool it's got several different uses that are really handy around the shop. And one of the ways that we're going to use it, and the way it's designed to use, is that you can actually stand it up on this end here, and you can use this surface here as a reference surface. So what I have done, I have got this adjusted almost near dead center to the height, top dead center of this shaft right here. And I'll show you what I mean, because I've already got this set. I used an indicator and I swept across the top of the shaft. And once we had our top dead center with the indicator here, I was able to adjust this shaper gauge so that when the needle comes across and touches the shaft on 0, it comes over here and zeroes out as well. So now we can actually move this out here on the table wherever we need to. Once we have our cutter set up in the spindle, we can come over here and touch it off. We can just do this by hand instead of the machine running, and we'll be able to find our Z right there using that. So we'll get the indicator set up and I'll show you what I mean. All right, we'll see if we're still set up, but this is the indicator base that I'm using. I don't have a height gauge or anything like that to use here now. I just haven't I haven't brought anything down from the hone shop. But this will work. What I did was I used my precision flat stone, and I stoned the bottom of the mag base there to make sure there wasn't any burrs that was catching. Cleaned off the top of the vise. Now all this should be nice and parallel to the table here, the way these Kurt vices are manufactured. If you're worried about this, you just use your table as your reference for your indicator base here. But we're going to go ahead and I'll sweep this across right there where I've got it marked, and that should come right up to the 0. You see it? All right, so that is our 0 point. That's our top dead center of the shaft. We'll come on out here, and what I'll do is go ahead and just lock the mag there, and I'll take the planer gauge and we'll sweep it underneath, and you see it comes up to 0. And that's why I said we're near perfectly 0. So it may be a few tenths off one way or the other, but that's not going to hurt us with what we're doing there. So this surface here is now referenced to the same elevation as the very top of the shaft. So we can use this to find the edge with our cutter and then make our Z offset. Now alternatively, you don't have to match the top of the shaft there. You can actually adjust this to the exact center height that you want the edge of the cutter to be. And this is how this tool was used a lot on big planers and shapers. If the machinist knew exactly the distance that he wanted that tip of that tool to be coming across to make the cut, they would adjust this tool using either calipers or micrometers. And once they had it set, they would use this and they would touch their tool to the very top of this surface, either this surface, or they would have it flipped this way. You could use this surface, and there's also round pins that screw in here as well so that you can increase the height if you want to. And I've got that pin there in the toolbox as well. But this was a really good way, a really good example of using a planer and shaper gauge, and I wanted to make sure you guys saw this as a way that you can use this to try to find the top of the shaft if you're in a situation like I am and you can't get over there to the top of the shaft to touch it off. All right, let's get this touched off now. So we've got our shaper planer gauge. I've got it just under the cutter there. So what I'm going to do is just work the Z handle here, the crank handle. We're only a few thousandths off, and I'm just going to move the gauge back and forth. And once I feel a little bit of friction, it should stop moving and we'll be exactly on the edge of that cutter. So I'm just barely moving the knee up. Just gonna keep working that. Very little movements here of what I'm doing. All right, there it is. Okay, so it just stopped. And you can see I can still actually pull it out. So we're matched. We're matched to the bottom of that cutter. So it's just like touching off on that shaft right there. So now we can move our Z offset to the center of the shaft. So this offset's pretty easy to establish here because we got an exactly 2-inch diameter. Our cutter's a half of that. So you take half of this, half of your shaft. That'll be 1 inch plus a 1/4 inch, 1.25 inches. We've got it set to 0, so count it up.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 makes 1 inch, 100, 200, and now we want 50.
250, so 1 inch, 250. And we should be right in the center of our shaft. And that looks good. Let's see if we can get a cool effect on the camera here. That's pretty cool. It looks like the cutter's not moving. So I film at 100 and, I'm sorry, not 120. We film at 60 frames a second. So I adjusted the speed of the mill to where it looks like that cutter is not even turning on the camera there. So that should be 60 RPM. It's right there. It's right almost on 60 RPM on the gauge. So that's the cutter. That's the RPM we're going to use to make our cut. All right, I'm going to get my flat established now. Just about there. That's it. I'm just going to touch it and Y this, zero the Y out. There we go. All right, we should be ready to go. So we're going to be going 495 thousandths deep on this one here. Get our coolant set up. Probably going to get quite a bit of chatter in this, but nothing we can do about it, but just let it eat. Everything's locked, spindle's locked, we are ready to go. Get a little bit more mist in there. It's actually not doing too bad. Just got to keep a little tool pressure on it. $150 thousandths to go. I'm going to set up and get you a closer shot of that. All right, we're gonna come in here and touch the depth just a little bit. What I've been doing is I've been sticking the key in there and using a mic to measure it and matching what the original shaft is. And we're just making it that. These are actually extra tall keys, so the stick out isn't the standard that's listed in the book. About 10 thousandths to go here. That was exactly ½ inch where I had stopped. I'm coming into 0.510. Just right there. We're gonna let it dwell just a few seconds here, just to kind of clean up that bottom. And that should put us right about where we want. I think if we're off a few thousandths, it's not gonna kill the job. There's probably adequate clearance over this key in whatever the hub or part that goes on here. We're just gonna try to square it up the best we can. And then let me grab my mic. This is kind of a little bit of an awkward, and now I got the camera right here, so just want to try to get it in the center as close as you can. Basically just try to get your mic squared up. All right, perfect. We're at 396, so 394. What I mic'd over on the old shaft was 2.395. So I'm 1,000ths deeper on this cut right here, that means we're where we want to be. So that guy is done. All right, so we just finished our first two. I still have one to cut right here using this size cutter, but I'm gonna have to move the vise set up in order to be able to hold this with the two vices. So this one's gonna come last because we gotta move it around. So since this is on center on our shaft, I'm gonna go ahead and just flip the shaft over or flip it around. And we're gonna go ahead and finish out these two right here. And then we're gonna move our vise set up and everything so that we can get to that last key right here. We got our Woodruff and the straight key to mill on this. That way we can move this down over here to our table as we need. I had to stretch the shaft out this way a little bit further, which was gonna make it heavy on this end. So I used a stack up of the Fireball tool magnetic blocks there for our 2 7/8 bed height that matches the Kurt right there. And if you mic that, it's just dead on it. We've also put the Woodruff key in here, and I'm using a machinist square coming up right up to the face of that key or the top of the key. And I have got it just as square as I can get on that key right there. Whenever I'm looking down it, looking that way, I can't see any gap anywhere. So we've got these keys squared up, and it's tightened up where we need to do. Now we need to tighten up this other vise on the outer end here. So I left this loose so you can see what I'm talking about there, and it's all cleaned out. So we're just gonna use the vise jaw and just pull it up square. I'm gonna loosen it up, just kind of let it spring where it wants to go. And that's it. Just give it a little snug up right there, and then we'll tighten down our strap clamps on both sides, and that'll be good to go. All right, we'll give our depth a check. We'll just use our calipers here. That's gonna get us close enough what we need to know. Should be 1 7/8. It looks like right around 1.87, 871 maybe, so that's actually really good. According to the book, you got a 5/1000ths tolerance there, so we hit that one right where we need to go. Just doing a reference check with the calipers here. That is spot on what the original shaft is there. I got this one a little bit tighter than the first Keyway. That's awesome. That one is ready to go right there. All right, well, the KBC mill is doing really well on this. I'm real happy with it. We've got our 4 Woodruff keys milled. We've still got to do one more Woodruff here with the straight key, so that's what we're gonna do next. I'll get everything cleaned up, and I've got to refigure the vices here, get it trammed back in, and we'll come back and do that. But I was gonna say, I was real happy with the way the cutter has been performing. And as I was hand feeding this, I was realizing that if I tried to feed it too hard, too fast, that's when it was trying to do a lot of that chatter. And if I slowed down and just kind of eased into it and just felt it, you know, this is part of manual machining right here a lot of times, is that you're feeling the machine out, you're letting it talk to you. And I could feel this thing, I could feel the cutter, you know, and if you tried to force it, that's when the chatter would come in. So I slowed down and just let it do its thing. And that thing really smoothed out, and it was taking a nice cut, and it wasn't making all that noise. So that worked out really well. The little stub arbor worked good, and our little cheap in-mill holder. So it's turning out really good. So I'll bring you guys back once I get all this cleaned up and we're ready to cut the other side, okay? Nice and straight. All right, we got our shaft ready to mill our keys there. Now I'm going to use my planer gauge here to touch off my tool. Our reference surface is still the same because we're sitting on the 2-inch journal in the vise there, so that hasn't changed. So we can still use this and then use the same offset that I calculated to get the center of this diameter right here. So we've got it real close. We'll just bring the knee up till we feel this just start rubbing, just like that right there. It's just touching. I can feel it just touching that cutter there. There we go. Okay. All right, let's get this last Woodruff key cut. We're ready to just go into our depth now. I cut that a little shallow so we could measure it, so I need to go in there about another 20 thou. Once we get to the bottom, I just kind of let it dwell for a few seconds, about like that. Bring it out. I'll measure it and see where we're at. Make it like the other two. This keyway depth here, I'm just matching what's on the original shaft, which was right around 2 inches and 3/32. So we are right there at that 2-inch 93. We're going to leave that one alone. I honestly don't think that this key is used, but as we said before, Andrew said, just go ahead and put it back in there just in case. That it's better to be there than not. So this Woodruff key's done. So we're going to go ahead and line up on the shaft now, and we'll use the same cutter to go ahead and mill the 1/2-inch straight key all the way out. And it's just a standard 1/4-inch depth, 1/2-inch wide keyway down the rest of the length of the shaft. Make sure we get our flat established. I think we're there. Come in and reestablish my 0 point. Right there. Come into our Woodruff, come back to our 0, and let's run this out just a little bit. I'm just going to make sure that we're on our flat. I think we need a couple more thousandths there. Okay, I think we're there now, so we can take our depth and make that cut. All right, we're ready to mill this thing out. We'll just use a slow controlled feed rate on this. Once it gets the full radius established to the cutter, it'll smooth it out a little bit. Got the edge of stone, got that burr off there. Let's see what kind of depth reading we're getting with these calipers here. I'm getting 248. 249, so I think that's going to be good enough there. I don't want to have to go back through there again. So I think we're going to be good right there where we're at. We want a 1/4 inch depth. All right, that's going to complete all of our keyways there. They're all finished up. I still need to do a little more deburring on them. We're going to get them out of the mill, and I'll do that over on the table. Do some dressing, but man, this shaft is finished up. It is ready to go. All right, guys, well, our shaft is now finished up for Andrew, our friction press shaft. I'm real happy with it. Turned out good. And all of our keyways matching up to the originals there. And then here's the two, these are going to be the two Woodruff keys that I sent, and as I was saying, so they're a little bit tight. Andrew can dress those if he'd like, so that they'll fit in there without having to bump them in there real tight. This side also, same way, a little bit tight. So these keys are, I don't know, about a 1/2 thousandths oversized there. And then all of our large Woodruff keys fit. This one fits just like it's supposed to there as well. Same as this one. And of course all of our threads are matching up good, so the flanges go on there. So this guy's done. And I had mentioned this in the previous video, but the holes, these holes are like not squared up to these keys in any particular way. I think they were drilled after everything was assembled. So Andrew is going to handle the holes himself. Like this guy's not even in the center of the shaft. It's offset a little bit. So Andrew said he would do the holes. He's going to tackle that on his end, or maybe have somebody do it there in Texas once he's got it all together. I'm not sure, but our job is now done. It's complete. Check him out on Instagram, Blacksmith Tools. I'm sure once he gets this press all put together and ready to go, he'll probably have some video of it running. It's a really interesting machine on how this actually operates and what they use it for. So final phase is to get this thing strapped up to a pallet so that we can get it shipped over there to Dallas for Andrew, and he can continue on his journey of getting this friction press restored and put together, because I think he's actually got a customer that wants to buy this from him. So I was happy to share it with you. I hope you enjoyed watching us get this thing machined in on our Precision Matthews and our KBC mill. And this one is done. We'll see you guys on the next video.